Hi friends, so my name is Aniket Agarwal and today we're going to talk about the topic called inequalities. Okay, let me put it on charger. What we're studying today is called inequalities. I hope I'm visible to everyone. I hope that visibility is proper. The topic that we're studying today is called inequalities. So, what are inequalities? We'll look at that. How inequalities are solved, we'll also look at that. Let's quickly start off. Okay, let's start by understanding the topic, which is called inequalities. Okay, so inequalities are basically statements where two quantities are unequal, but a relationship exists between the two of them. Okay, these type of inequalities occur in business whenever there is a limit on supply, demand, sales, etc. For example, if a producer requires certain type of raw material for his factory and there is an upper limit in the availability of that raw material, then any decision which he takes about production should involve that constraint. So we will learn more about such situations and how they can be understood and solved better using inequalities. Basically, in sales, in production, whenever there is any type of constraint or any type of limitation, that limitation is understood using inequalities. It is understood using the concept of it is solved better using the concept of inequalities. So let's understand what inequalities are all about. Let's look at linear inequalities first. Let's understand what linear inequalities are all about. Okay, so any linear function that involves an inequality sign is a linear inequality. It may be of one variable or maybe more than one variable, but it will be linear. Basically, the power will be 1. Simple example of a linear equality is with one variable, such as x greater than 0 or x less than equal to 0, etc. These are all linear inequalities. Okay, so basically inequality doesn't mean that these two are equal, but there is some form of relationship that exists between x and between 0. The relationship is that x is greater than 0, your x is less than or equal to 0. How this can be plotted? So inequalities are normally plotted using graphs. So how it can be plotted? On this graph, I will have to have you assume that this is a straight line, although it doesn't look like one. I'll say that this is the origin, this is 1, this is 2, this is 3, etc. This is -1, this is -2, this is -3, etc. So x greater than 0 is basically this side of the line, and it will coincide with the line. For representation purpose, I've shown it a little above so that you understand that this is the line that I'm trying to represent. X less than, and this will not include this point, which is the origin, which is x equal to 0. On the other hand, the other inequality, x less than equal to 0, can be represented on this side of the line, coinciding with the line and going up to infinity on the other side of the x-axis. And this includes, which is equal to 0, it includes the point 0, which is the origin. Okay, so I hope this was clear for everyone. All right. Let me make this more clear by representing this on one side with black color and the other side as blue color. So this black line represents this equation and the blue line represents this equation. Coming back to the original color. Okay, so this is how inequalities are plotted. Now let's say that there is a linear inequality in two variables. For example, 3x plus y is less than 6. Now how do you represent this inequality on a graph? So the method includes first plotting the straight line, which is 3x plus y is equal to 6. How this line can be plotted on a graph? We assume values of x and y. Okay, we create a table here. We assume values of x and y. Two values of x and y, points which satisfy the given equation. So when x equal to 0, y is equal to 6. When y equal to 0, x is equal to 6 upon 3, which is 2. So basically, to plot this line, you draw a graph in xy. And I use a straight line here. Okay, never mind. So you will have to just bear with my handwriting here and assume that this here is a straight line and even this here is a straight line. We'll assume that this line represents x and this line represents y. We'll use the blue line here. Okay, so this is 1, 2, 3, 4, 5, 6, 7 onwards. 1, 2, 3, 4, 5, 6, 7, 8, 9 onwards. This is origin here. We will assume that this is the origin, this is the x-axis, this is the y-axis. Okay, it is not, the diagram is not to scale, but the idea is to make you understand the representation. The first point is 0, 6. 1, 2, 3, 4, 5, 6. Here also, let's give it numbers. The first comma is 0, 6. 0, 6 will lie on the y-axis. It is this point here. This is 6. The other point is 2, 0. So 2, 0 will lie on the x-axis. Now this straight line over here by joining these 2 points is the line that represent the equation 3x plus y is equal to 6. Now to represent this inequality over here, since it is less than 6, the line will not be included. But to find out that on which side of this line, whether on this side or on this side, this inequality is satisfied, what we will do is we will assume a point from this graph and put it in this equation in its inequality to see if the value is fulfilled. So let's assume a point origin, which is 0, 0. If we put origin over here, 3 into 0 plus 0 is equal to 0. Okay, So we are assuming the point origin, which is 0 comma 0 in this inequality. It is 3 into 0 plus 0 is equal to 0, which is definitely less than 6. So the point origin satisfies this inequality. So the solution set lies on this side of the line. Okay, so solution set, if it is less than, will lie on one side. If it is greater than, it will lie on the other side. If it is less than equal to, it will include the line. If it is greater than equal to, it will also include the line on the other side. Just to reconfirm that no point from this side lies in the solution range, let's take a point 4 comma 0 and see if it satisfies the inequality. 4 comma 0 is 3 into 4 plus y is 0, which is 12, which is greater than 6. So it does not satisfy the inequality, which is less than 6. So we can safely say that this point does not lie in the solution range. So basically 3x plus y less than 6 is denoted by, is identified by this region here, and it does not include the line 3x plus y is equal to 6. Okay, so this is the solution set for the line for the inequality 3x plus y is less than 6, not equal to. Okay, so I hope everyone got this. This is how inequalities are plotted on a graph. Let's look at what type of questions get asked in the exam. Okay, before that, let's solve this another problem. This is also an exam problem. Okay, let's see what it says. You have to draw a graph which shows the problem, the solution set for the following inequalities: x greater than equal to 0, y greater than equal to 0, x is less than or equal to 6, y is less than or equal to 7, x plus y is less than or equal to 12. So this is what is shown. This is what we have to plot. For this, we first solve the equation x plus y is equal to 12. We find the values of x and y. If we assume that x is equal to 0, y becomes equal to 12. If we assume y is equal to 0, x becomes equal to 12. Okay. So let's see how that will look on the graph. Again, assume this is a straight line. Also assume this is a straight line. This is x, this is y, this is the point origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. This is the point 0, 12. This is the point 12, 0. Basically, the line x plus y equal to 12 is denoted by this straight line. Extend this further. So I'm having you guys assume that this is the entire thing is a straight line. I know it doesn't look like one, but you still have to assume. Okay, now this is not acceptable. This will have to go. For that, I need an eraser. Okay, go back to a pen. So we'll say that this line here is, the straight line is x plus y is equal to 12. That is one straight line. Okay, less than equal to, let's see which side it will fall on. Let's take the point 0, 0. So 0 plus 0 is 0, which is less than equal to 12 for sure. So origin lies in the solution set. So basically the solution lies on this side. Now let's plot another line. Which is x less than equal to 6. For that we'll assume the point, the line x is equal to 6. X equal to 6 will be 1, 2, 3, 4, 5, 6. Will basically be a straight line which passes through the point x equal to 6 and will be perpendicular to the x-axis. This straight line here is x equal to 6. You will have to assume that it's a straight line. Similarly, y equal to 7 will be a straight line here, which is 1, 2, 3, 4, 5, 6, 7, which will again be a straight line which will be perpendicular to the y-axis. This will be y equal to 7, this will be x equal to 6. You've been given that both x and y are less than 6 and 7 respectively. So the solution sets will lie on this side and this side of the line respectively. You take any point inside this range. Take 0, it will be less than 6. Here 0 will be 7. So we know for sure that these particular ranges give the solution set for x less. Basically, the result, the solution set will be inside of the first quadrant, which is inside the x-axis and the y-axis. It will be inside this line over here. It will be inside this line over here. It will be inside this line over here. So this is the area where all the given lines are merging or coinciding, and all the solution sets are merging and coinciding. It cannot go beyond the y-axis as y is greater than or equal to 0. It cannot go beyond the x-axis as x is greater than or equal to 0. So this area here will mark the solution set for the given set of inequalities. So the solution set will be this, and this will mark the set of inequalities that are given. So this will be the final solution set. I hope this is clear for everyone. Let me take another example. Okay, let's look at another example. This time let's look at something little more complicated. For that, first let's understand what kind of real-time problems can be solved using inequalities. Let me read out a question for you. The question says that a company produces two products. Okay, I'll go back to the black color first of all. It's much easier to read, right? Question says there is a company and the company produces two products, A and product B, each of which requires processing in two machines. So machine 1 and machine 2. There are two machines in which A and B have to be processed. the first machine can be used at most for 60 hours. The second machine can be used at most for 40 hours. The product A requires 2 hours on machine 1. Two hours on machine 1, and it requires 1 hour on machine 2. Product B requires 1 hour on machine 1, and it requires 2 hours on machine 2. Okay, so you have to express this given condition using inequalities. How will you do that? Let's have a look. So let's say the company produces X number of product A, and it produces Y number of product B. Now to represent the given inequality, let's draw a simple table here. This is product A, this is product B, this is machine 1, this is machine 2. So the total here has to be 60 for machine 1, the total for machine 2 has to be 40 hours. Okay. First product requires 2 hours in machine 1, and it requires 1 hour in machine 2. Product B requires 1 hour in machine 1 and 2 hours in machine 2. The total number of product A which is getting manufactured is X, so this is 2x. The total time will be 2x in machine 1 and 1x in machine 2. For this one it will be y in machine total. The total here will be y in machine B, and 2y y in machine 1 and 2y in machine 2. So this is the table which can represent the relationship between the two products and the two machines. Now to simplify this further, if we write it in the form of equation, we know that for the first machine, the equation will be 2x plus y has to be less than or equal to 60, because the machine can be used at most for 60 hours, and in this case it will be x plus 2y is less than or equal to 40. So these are the two inequalities that represent the given problem set. Okay, and once we plot this on the graph, we will know the solution set which is required for this given inequality. Now we have not been asked to represent this on the graph, but that is how problems are solved, by representing on the graph, finding a solution set, and then finding the most optimal solution for the given inequality. Okay. Alright, so I hope this is clear for everyone. I hope this question is clear. Let's move on to the next question. So I'm basically giving you all the type of questions that can be asked in the exam for representing inequalities and etc. So basically the question is, draw a graph of the inequalities 5x1 plus 4x2 greater than equal to 9 and of the graph of the inequality x1 plus x2 greater than equal to 3, x1 is greater than equal to 0 and x2 is also greater than equal to 0. Now you have to mark the common region of the solution set for all of these inequalities combined. We already know how to solve this. We first find the value of x1 and x2 for the straight line is equal to 9. So in this case, if x1 is 0, x2 becomes 9 upon 4. If x2 is 0, it becomes 9 upon 5. Similarly for x1 and x2 for this given equation, x1 plus x2 is equal to 3. x1 is 0, x2 is 3. If x2 is 0, x1 is 3. So these two tables give us the value of x1 and x2 for the given two lines. Let's try and plot the graph for the two lines and then we'll take it from there. Okay, so let's say that this graph here represents x2 and x1. This point O is called the origin. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This point here is the origin. Okay, let's first plot the first line. 9 upon 4 is basically 2 point something. So this will lie somewhere over here. This is 2 point something, 0, 2 point something. So this will be somewhere over here. Another point is 1 point something, so it will be closer to 2, somewhere over here. 1 point something, 0. So this is 1. You just draw a straight line joining these 2 points. Extend this further. This line represents 5x1 plus 4x2 is equal to 9, and now let's plot another line, which is 3, 3. So 0, 3 and 3, 0 are the 2 points which are to be plotted. Okay, I assumed, my bad, this is not 3, 3, this is 4, 4. The 2 points will be 3, 3, 3, 0 and 0, 3, which is these 2 points. Okay, so this will basically be a straight line joining the 2 points. Assume that this is a straight line. Okay, see, the best part is you don't have to draw these graphs in exam, so you don't have to rely on your handwriting. This line here is x1 plus x2 is equal to 3. Okay, so the solution set for the first line is given by x1 plus x2, 5x1 plus 4x2 is greater than equal to 9. Let's assume if point 0 plus 0 is not greater than equal to 9, so the solution set for this line lies on this side. Similarly for this line, 0 plus 0 is not greater than equal to 3, so the solution set again lies on this side. The solution set and x1 and x2 is greater than equal to 0, which means the solution is confined to the first quadrant. So the solution set will be given by the Okay, let me use a different color to highlight the solution set. The solution set will be represented by this area here where the two lines coincide on both the sides. This here will merge with the x-axis, this here will merge with the y-axis, and this will give us the solution set. So basically this is how problems based on inequalities are solved. I hope you understood the basics. We are solving more problems in our plus classes. We have done an entire course on inequalities where we have solved a lot of problems. We looked at exam based problems. So if you are looking to join the plus course, you can use our discount code, which is capital L, capital P, R, O. This is L, this is P. So capital L, capital P, capital R, capital O. So this is L Pro. You can use this discount code to join the plus classes. If you have any of your friends who are looking to join, you'll get a straight 10% off if you use this discount code. I hope to see all of you there in the plus classes. If not, we'll meet again very soon in a YouTube live or a special session. Okay, so I hope this session was useful. Have a great day, everyone. Bye bye. Enjoy.